Hello everyone, it's Benny, and welcome to part 3 of implementing Variance Shadow Mapping. Now, in the last 2 parts, we created a basic implementation of Variance Shadow Mapping, and we ironed out most of the kinks with it. We've basically solved the light bleeding and the shadow acne issues. So, it's almost there. But we still have those really awkward stair-stepped shadow edges. And if you want to, we've actually already discussed one way you can overcome this. I made a video on percentage closer filtering, and that's a perfectly valid way to overcome that. If you take the percentage closer filtering function from that video and just replace the sample shadow map function with the sample variance shadow map function, that would solve this problem. But variance shadow mapping actually offers you another way you can overcome this. The thing is, because a variance shadow map is storing a mean and a variance rather than an absolute depth value, you can actually pre-filter the shadow map. That's the reason we have this basic linear filtering on the shadow map already. So what you can do is you can actually go ahead and apply the percentage closer filtering to the shadow map directly before you start sampling it. And that way, you don't have to do any filtering in your fragment shader at all. You can just read from the variance shadow map like normal, and you have nice, smooth, filtered shadows with almost none of the performance cost. It's scarcely more expensive than just basic shadow mapping. So that's what we're going to be talking about in this video, and then we're going to go ahead and make our code a little more general, and we'll go ahead and wrap up this discussion of variance shadow mapping. So let's get to it. Now, if you remember from the last video, I said that a variance shadow map at 1 pixel is supposed to store the average depth and the variance of depth over some area of depth values. Okay? Now right now in our shadow map generator, we're not storing any area of depth values, we're just storing the depth of one value. So all we have to do to get some area of depth values is, well, sample it and store that in the shadow map itself. And you could do this with percentage closer filtering, or you can do it with just a basic Gaussian blur or something like that. And in fact, that's exactly what I'm going to do here. I'm going to create a filter shader, and after we generate our shadow map, we're going to apply a Gaussian blur to it. And then we're just going to sample from that. And because we're storing the average and variance, we get to sample from the Gaussian blur. And you know, it's cool like that. So yeah, let's go ahead and do that. I'm going to add a new function to our rendering engine. It's going to be void. It's going to be called applyFilter. Now this is going to be a little bit interesting. It is going to take in a shader pointer for the filter that we're supposedly applying to it. So that's nice just for there, because that means we can program whatever filter we want, just pass it in as a shader. But the interesting thing is, we're going to take in one texture pointer for the source and a texture pointer for the destination. See, here's the thing. OpenGL doesn't allow you to read and write to the same texture at the same time. So we're not just going to be able to read from our shadow map, blur it, and then write it back out. It's not that simple. We're going to have some intermediate texture to, well, so that we can write to that. And conveniently enough, that actually allows us to make our blur significantly faster. But, you know, still, just something to keep in mind. You can't read and write to the exact same texture at the exact same time. So anyways, I've gone ahead and added the function to our CPP file. And since source and dest can't be the same, the very first thing I'm going to do is I'm going to do an assert. I'm going to assert source is not equal to dest. So that's the first thing. The second thing I'm going to test is if dest is equal to 0. Because if it is, then I'm going to use that as a sort of, I don't know if this is the best way to put it, but it's going to be sort of a particular value that's going to indicate that we want to render to the window. We want we want the window to be the destination. No, and otherwise, of course, we're going to take the dest and bind that as the render target. So cool. And that set everything up. Now, this is why I saved that temp render stuff, because, wait, no, it's not the temp render I was trying to save. Well, I know I saved something somewhere for this. Oh, it was the temp render stuff. Never mind. Never mind. Because, yeah, this is doing exactly that. Wait, no, this is rendering a plane. Okay? It's rendering a plane over whatever area our render target is. And that's exactly what we want, because we want this filter to apply to the entire target. So, yeah. So I'm going to clear the depth buffer bit. Don't need to change the clear color. I am going to switch main and old camera. Probably going to set up old camera in a moment so that, it's set up properly. In fact, I can just copy this. Well, almost, but, I can copy and modify this. I'm going to set the rotation to, that. I'm going to set set rotation to that. I'm going to set the position to just default, because, well, we don't want any special position for this. We just want, a basic at the default location, because I believe the plane is offset for that. Unless I'm mistaken. No? Well, in any case, something is set up so that works. So, there you go. And great, so position is good, rotation's good. All I have to do now is change the projection to identity. So, alt camera, set projection. Still not working for some reason. Okay, but it's going to be matrix 4f dot init identity. So cool. And there, I think that's almost everything we need to set up. I think that does draw the plane though. So great, we now got the plane being drawn, and yay, we got a way to apply a filter. Only thing left is we're of course going to need some way to access the source texture from the shader. So up here, I'm going to set a texture. I'm going to call it filter texture. So this is a texture we're filtering, and we're going to set it to source. And at the end of this function, I'm going to set it to 0, because remember, our superclass will delete all attached textures, well, in the destructor. So we probably don't want that. So I'm just going to set my filter texture to null, so we don't have to go randomly deleting it at the end of things. And there, I believe that's all we need to do to set up a basic filter function. So with that, I'm going to create a new texture. I'm going to just copy my shadow map texture, the one that initializes it, and I'm going to name this texture Shadow Map Temp Target, because that's what this is the temporary, it's temporary texture that we're going to use for the destination in this whole filtering thing. Oh, and make sure you're using the filter as a shader here, not the default shader. So, yeah, just be careful of that. Let's see. Okay, other than that, I think I think everything's working there. So, first off, let's build and run to make sure I haven't destroyed anything just yet. And while that happens, and up here, we're going to, of course, need to include cassert if we're going to do any assertions. Oh, and apparently, I forgot. That has to be a quaternion of that. Okay. No errors. Good. And let's run just to make sure, Didn't think so, but always better to be safe. Now I'm going to create a new shader. And following the sort of dash convention I have with, like, forward rendering, where I'm prefixing everything before to indicate it's a shader for forward rendering, I'm going to prefix all the filters with filter to, just indicate that, well, they're filters. And this one I'm going to call null. So this is going to be the null filter. It doesn't actually do anything. I'm going to create another one for that. Filter null.fs. And there. So let's... Oh, right, I forgot I had that open. Yeah, so let's just go ahead and open those. And... in fact, let's open forward ambient.fs and vs as well. Because I'm going to just copy those to start with. At least I think I am. Gonna open. Okay. Well, apparently I already have it open somewhere somehow. And it's not showing it, but whatever. It's okay with me. Oh, I didn't open it. It's FS I need to open. Much more sense. Okay, never mind. Sorry, getting a little bit discombobulated, but that's okay. So for my null filter, VS, and FS, I'm going to start by copying the ambient shader. Okay, I'm just going to modify it from here. Now, filters, fairly simple. We're not going to need any normals or tangents, so we can just get rid of that. Or even world position or TBN stuff. Yeah, just get rid of that. And really, I can get rid of all this too. We're just going to need the position and the texture coordinates. So that means the varying variables only going to need to be the texture thing. We're not going to need sampling stuff. And yeah, the only uniform we should need is a sampler 2D called r_filter texture. Because that's what we're putting in as, you know, the filter texture. So there. All we have to do, in our null shader at least, is output the filter texture. So, yeah. Gonna sample the filter texture, and with the texture coordinates. Oh, texture coordinates 0, I should say. And I believe that's everything we're going to need, so... yeah. I'm gonna add another shader, another shader, to this whole list. I'm gonna call it null filter. So this is a filter that supposedly doesn't do anything. And yeah, it's just gonna be new shader, filter null. Build, make sure it doesn't crash. Okay, doesn't look like it's crashing, so what I'm gonna do right here at the end is I'm gonna say apply filter, using the null filter with my source as, well, get texture shadow map, and my dest as get texture shadow map temp target. So this is just to test our filter system to make sure it's actually working. And, well, you know. And I'm going to swap those parameters. I'm going to do it again, swapping the parameters. So this should do nothing. This is basically just going to copy the shadow map to the temp target, and then copy it from the temp target back to the shadow map. So let's build one last time. Let's just make sure this works. Okay, it doesn't. So clearly I've done something wrong. So I'm going to let this build off screen, and I'll see what I've done wrong. I'll be right back. Okay, I just made two small oversights. First, text coord 0. Yeah, there's no S here, just text coord 0, not text coords 0. So, yeah, be careful of that. Second thing is, where is it? Ah, right here. I'd left a window bind as render target right here, so everything was being drawn in the window, and, well, that's not very nice. So, yeah, make sure that doesn't happen. But other than that, if I build and run, you notice, hey, look, the shadow map looks exactly the same. So, I think that's a pretty good indicator that our null shader is working. It's actually doing nothing. Good. So let's make a new shader. I'm actually just going to start by copying the null shader, or filter, excuse me. This one I'm going to call filter-Gauss blur 7x1. So, yeah, it's quite a name, but yeah, we're just making a specialized Gauss blur for our shadow map. And that's strange. Oh, I thought the Gauss blur things disappeared, but no, it's just moved to the front. Okay, good. So now let's open up, and let's begin. So what I'm going to be doing here is I'm going to be taking in, well, before I do that actually, first off what I'm going to be doing is I'm going to be having some vec4 color. This is going to be the result. It's going to start off as a vec4 of absolutely nothing. And then at the end of this, GL frag color is going to end up being color. So yeah, this is our Gauss blur. And what I'm going to do is I'm going to have another uniform here. This one's going to be... Okay, I'll put it under the sampler because that's going to bother me. I'll put it above the sampler. It's going to be a uniform vec3 that I'm going to call r underscore blur scale. So this is... Actually, I think it's easier just to show you. So I'm going to take color, and I'm going to add something to it. And, unsurprisingly, this is going to be sampling our filter texture from somewhere. But what I'm going to be doing is I'm going to be offsetting the texture coordinates by a vec3 of... Now, this is 7 by 1, so in this case, the vec3 starting at -3, and we'll go -2, -1, 0, 1, 2, 3. And I'm going to multiply that by the blur scale. So this is just a way of, well, controlling how much it's offset. And additionally, well, blur scale.xy, excuse me. So this controls not only how much are we offsetting, but also in what dimension are we offsetting. So we can use this as a shader for blurring both on the x-axis and on the y-axis, which is kind of nice. There. And I'm just going to do this 7 times. That's 6, I think. Wait. Yep, that's 6, so I need 7. And just like before, or just like I said, I'm going to go down to 0, then 1, whoops, and then 1, 2, 3. So cool, we're counting down, going off that way. Now here's the thing. We need to weight this by some amount. And I'm not really here to talk too much about Gauss blur, so I'm just going to say these are the Gaussian weights for a 7 by 1 blur shader, or yeah, a 7 by 1 Gaussian blur. And you can either take my word for it, or you can look more into Gaussian blur. I don't know a concise way to explain where the blur weights come from without spending more video time than I'd like on it. But in short, the furthest ones away from the center are going to be 1.0 over 64. So, there. And, in fact, everything's going to be a fraction of 64, so don't know if that gives you any insights, but yeah, it's true. Now, so the -3 and the +3 are going to be 1 over 64. The 2's are going to be 6 over 64. The -1's are going to be 15. And, yeah, the center is 20 over 64. And those are the proper weights for a Gaussian blur. And with that, we now have our blur all set up. Assuming I did everything right, which I think I did. So, well, let's go in, and let's add a new function to our rendering engine. I'm going to call it blur shadow map. So it's going to take a texture pointer, shadow map, I'm taking it as a parameter just because, well, you know, and a float blur amount. So there, just a nice, easy way to use the function. And this is going to be right above our apply shader. You might be wondering, hey Benny, why aren't you just using the apply filter with Gaussian blur? Don't worry, I have a plan. You'll see in a moment. And of course, I also want a new filter for this, so I'm going to copy the null filter shader. I'm going to name this filter Gauss blur 7x1 in Gauss filter. I'll say Gauss blur filter, I think it's more appropriate. And finally, in my header, I'm going to declare the Gauss blur shader. So, yeah, you know what? Let's just make sure this builds now, because I may have screwed something up. Also, make sure you're deleting all your shaders in the rendering engine destructor. And it looks like it's building, so good. Now, here's why I am having a separate function for blurring the shadow map. I'm actually going to be blurring the shadow map in two passes. One pass for the x, and one pass for the y. And I'm going to be setting the blur amount, well, set vector 3f. I called it, what did I call it? Blur scale. I'm going to be setting that to a vector 3f based on, well, which axis I want to blur first. So I'm going to start by blurring the x-axis. It doesn't particularly matter which one you start with, but I'm starting with x. And the way I'm going to get that amount is I'm going to take the blur amount, and I'm going to divide it by shadow map get width. Do I not have a get width function? Oh my word! My texture does not have a getter for the width and height. What's up with that? But well, alright, I guess I'm going to go ahead and add them. Okay, so I went ahead and made getters for it. All they're doing is they're returning the texture data or get width, and those, again, I had to add because I didn't have them. They're just returning in width and in height, basic getters and setter, or well, just getters actually. Also, I realized while I was doing that, I don't know exactly what I was thinking, dividing the doing blur amount over get width, because what I actually want is texel size, right? So I'm doing 1 divided by shadow map.get width, and I'm multiplying that by the blur amount. So this way, essentially blur amount is going to be a way to tell me how many texels should I sample at once. So I'm going to move 1 texel over at one time, I'm going to move 2 texels over at a time, I'm going to move half a texel over at a time, etc., etc. So there, that's a blur scale. And after that, I'm going to apply the filter. So I'm going to apply Gauss blur filter with the shadow map, and the destination, of course, is going to be get texture. Well, actually, I think I have it down here. Yeah, get shadow map temp target. Much better. So there we go. We're applying the filter there. We've now successfully blurred our shadow map on the x-axis. Here's the thing, though. What I'm going to do now is I'm going to do that same thing again, except on the y-axis. And you might think this is going to be sort of an approximation of what the blur would be, you know? It's just doing it in the cross rather than taking all the diagonal stuff. But oddly enough, well, first off, just before I get ahead of myself, what I did here is I switched around x and y, and now I'm switching around the shadow map temp target as the source, and the shadow map itself as a destination. Okay. Anyways, now you might think that if I blur a shadow map like this, first on x and then on y, that it would just sort of blur in a cross. It wouldn't actually take into account a full square of area. But actually, it does. Because this second time, I'm not blurring from the original texture. I'm blurring from the texture that's already blurred on the x-axis. And since already blurred on the x-axis, well, all those x values are, properly averaged. They already have taken into account all the, all the diagonal stuff on the x-axis. So all you have to do to get the final result is blur on the y-axis. So yeah, it's one of those things. It's a 2-pass way to blur something, and it's very efficient like that. So yeah. Anyways, I think I've rambled on about that all long enough. Let's blur the shadow map. So I'm going to start by, just passing in get texture shadow map as a shadow map, of course. And the blur amount's going to just be 1 in this case. So we're blurring 1 texel at a time. Or, just doing a basic blur. 1 texel. Yeah. Yeah. So, let's build and run, and let's see what happens. We crash. So I've probably screwed something up in the shader again, so 1 moment. And it was very simple. I simply put vec3 here rather than vec2, because, these are vec2s. We're multiplying them by, vec2 stuff. So now if I run, look at that! We've got nice, smooth, blurred shadow maps. And It's that simple. So now we've got very nice, soft-edged, smooth variance shadow maps. And we can control, you know, how much this affects things. So if I turn this up to, say, I don't know, hang on, let's try 0.25. I'm curious what that does. Oh, that actually makes it softer. Alright, I guess that does make sense. Okay. So yeah, now we got really soft shadows. And yeah, so there you go. That's making soft edge shadows with this stuff. The only thing now, I suppose, is just take all these different variant soft shadowing things, like, well, for one, the blur size and the... where is it? Is there a sampling? Ah, yes. And things like this right here, the, well, you know, the variance clamp value, and things like this, which will be the light bleeding value. You know, just taking all those things and making them uniform so we can control them, you know, per shadow. And I'll show you how to do that, and then I think we've just about wrapped everything up for this video. So, in lighting.fsh, I'm going to take in a few more uniforms. It's going to be uniform float, r underscore o, I'll start with shadow variance min. So that'll be the minimum shadow variance. And I'm going to take one more float that I'm going to call, not variance min, but rather, well, how about this? R shadow light bleeding reduction. So there. And I'm going to take those in as parameters to sampling.gl. So, well, you know, the sample variance shadow map function, excuse me. So after compare, I'm going to take in some float I'm going to call variance min, and some float I'm going to call light bleed reduction amount. Sure. So light bleed reduction amount is going to be what's as that for the lens step, and variance min is going to be this 0.00002. And all I have to do now in lighting main is just pass in those the uniforms as those parameters. So right here, you can pass in variance, shadow variance min, and here I'm going to pass in our shadow light bleeding reduction. And that should be everything I need there. So I think, I could be wrong, but I think we're actually done messing with the shaders now. So that means in lighting.h, I can change my shadow info. I'm going to comment out the actually not the flip faces, but I am going to comment out the bias because that's no longer needed. In fact, I'm going to get rid of it even. We don't need bias anymore, not with variance soft shadows. So, we no longer need bias, but we do need a float for one. Actually, we need several floats. First off, I'm going to say variance min. In fact, that's probably going to be my last parameter. And I'm going to need... in fact, let me just go ahead and set up all the parameters off screen, and I'll tell you what I'm adding. Okay, so, just like in the shader, I do have variables for the minimum variance and for the light bleed reduction amount. But I also have a parameter for the shadow softness, and that's going to control how much we blur the shadow, essentially. Well, yeah, it's going to be the blur factor to our blur shadow map function in the rendering engine. So, there. And also, min variance is the only parameter that I have a default value for. In this case, it's just what I had in the shader, 0.00002. But again, you can make that as much or as little as you want. In fact, I'm going to add a default value for the light bleed reduction amount too. I'm going to set that to default to just 0.2f. Because I think that... you know what, sure, let's add default parameters to everything. Shadow softness, I'll default to... yeah, no, not 0. I'll have default to 1. And flip faces, I'm going to have default to false. Well, actually, I'm going to have them specify that. And there. So, I think that's just about all the new parameters I need for this. So, in directional light, I'm going to change the parameters. No longer have a need for shadow bias. And in fact, I think I'm going to leave everything else at the default parameters, so yeah, there. Nice and simple like that. But we are going to need to change this. We don't need any shadow bias anymore, so I'm going to change it to what I have in my in my shaders. So I'm going to set a float, shadow variance min, to shadow info get minimum variance. And I'm also no need to set shadow texel size anymore, so I can get rid of that. I am going to need to set the light bleeding amount, so set float of shadow light bleeding reduction amount to the info get, guess what? The light bleed reduction amount. And I think that's all we need to do there, so that should be good. All we should need to do now is set the blur shadow map amount to shadow info get, shadow softness. And we should be not good to go. Okay. Well, apparently oh, I put a semicolon where I shouldn't have. Okay, much better. And with all that in place, we should now have, well, again, once we add parameters to the lights, because, again, I'm saving that for the next video, because we're going to be making this shadow map support all the different types of lights. Well, almost all of them. You'll see. But yeah, after we do that, then we'll be able to have, that thing, the... Come on, you know what I'm trying to say. Constructor parameters, there. And great, so we've got nice, soft shadows. By default, they're being dynamically generated. My screen recorder does not like them at all, but hey, it's there. So great, that's Variance soft shadows, folks. We got nice, soft shadows using Gaussian blur. And, so, hope you enjoyed, hope you learned, and I'll see you in the next video, where we're going to be extending our shadow mapping code to be more general, to support other types of lights just sort of out of the box. We don't have to do 10 million pieces of tweaking to get the shadows just right for that situation, no. We want them to just work just by creating a light and have it run fine out of the box. So that's what we'll be working on in the next video. Hope you enjoyed, hope you learned, and I'll see you then.